All right. Здравствуйте. That's it. So switching back to English. Right. So I think we can begin now. My name is Petar Tahchiev, like you can see here, and I'm going to talk to you a little bit about Spring Data REST. I really hope that you guys have some basic understanding of what Spring Data is, because I'm going to cover some topics that are, well, not so easy and not so for the beginners. So let's move on. This is what we're going to cover today. Everything that you're going to hear today has been tested against the latest snapshot of release train Ingalls. And well, I'm going to begin a little bit about Spring Data JPA, and then the core of the whole story will be Spring Data REST, of course, and then we're going to have some time for questioning and answering at the end. Yeah. So, well, my name is Petar Tahchiev. That's my Twitter over there. You can follow me. I am originally from Bulgaria. I'm a mathematician. I graduated mathematics, but just so I turned into computer programming. I'm a founder of a company called Nemesis Software. What we're doing is we're building an e-commerce platform using a lot of Spring technologies. Yeah, we're using a lot of Spring Boot, Spring Data, Spring Data Redis, etc. I'm also a Maven developer, and about 6 years ago, I co-authored a book called JUnit in Action, second edition. Right, so, well, before I begin, I need to generate myself a project so that I can walk you through, and I explain you a little bit about what we are trying to do. And you just have to bear with me for like 5 or 10 minutes to do that. So what we have done here is we have set up a website called Nemesis Initializer. It's located under start.nemesis.io. And you can go and you can fill in some details of your project. And what this actually does is it's going to generate you a command on the right side that you have to copy and paste it in your command line. So we're actually building a Maven archetype so customers can easily bootstrap their applications, and they can very quickly have like a starter shop. Right, so this is going to generate now my project. Oh, not sure why it takes so long. Okay, so it's done. So if you go inside, you can see we've got cores, facades, and a storefront folder. So I'm quickly going to build this, and yeah, while this is being built, I'm going to walk you through this sample application and what it does. Well, it actually is composed of a lot of modules, because what we wanted to build is we wanted to build a modular application where customers will actually declare their modules as Maven dependencies, and on the fly they can include them or exclude them, and this way they get like a nice set of configurations that they want to use. And yeah, that's pretty much it. So we go into the storefront, and I'm actually going to start it. Spring Boot run profiles equals MySQL. And now, while this is being, this is starting now, I'm going to explain you a little bit about the requirements we had. So what we wanted to build, like I told you, is a modular application. So like when you can see here on this slide, we have a green box. Well, the green box is actually like all the modules together, but we also have a red box, which is just the, for instance, the commerce or the commerce module, and the blue box is just another module. So depending on what kind of configuration of modules the customer chooses, what we want to have is a totally different JPA entity. So this means another totally different database with its own columns and with its own foreign keys and etc. And the way to do it, well, if you think about it, it's quite challenging problem, because you're not only just touching the database and the JPA entities, but you're also touching the services and the repositories or the DAOs on top of it. So it's not that trivial to do. But this is what we wanted to do, so we had to come up with a solution. And, well, we came up with a solution which is, quite interesting. So, and this is where we started modifying Spring Data, because breaking the modules in the JPA entities into separate modules is not really that hard. If you think about it, it's all you have to do is like create interfaces. For instance, let me go to IntelliJ. For instance, you have a product entity, and it resides, like you can see here, in the commerce module. So what we have done is we have created an interface called product entity definition, right? And then this entity definition extends from abstract entity definition, from activatable, from catalogable, and it can do that because it's an interface. It can extend a lot of interfaces. Right, and inside of these, you got different, different helper functions like get PK, set PK, and etc., and all the others like JPA annotations that you want. Then, because this is an interface and JPA requires to have classes, what we're doing is, when the customer selects these and these and these modules, we generate the JPA entity on the client side. We scan the whole class path. We see what kind of modules they have selected, and then we generate a JPA entity on the fly. So I can show you very quickly JavaDay. So here in the core target generated sources, we got com, nemesis, platform, module, commerce, core entity, catalog. And now we have here the product entity that has been generated, right? And it kind of looks ugly. It's because, it has been generated, so that's what it says, do not modify it. And again, it implements all these interfaces on top, and these are the JPA annotations that we copy. So that's pretty much how it works. And this way, you make sure that your application is kind of modular. Now, the next problem you have to solve is that, repositories need to work with JPA entities, and Spring Data repositories need to work with classes. So if you give them these interfaces that we have here, like the product entity definition, they're just going to say, I don't know what it is, and I'm not going to work with it. And for that reason, you have to tweak a little bit Spring Data JPA to make it work. So, like for instance, if you see here the product repository that we have, the product repository is just the Spring Data repository, which is, again, an interface, no implementation, and it extends, again, from activatable repository and catalogable repository. Right, back to my presentation. Right, so what we have done is we have created the JPA entities as definitions in each module, and then the entity classes are generated on the client side. The repositories are also inside the modules, and we have defined a custom JPA repository factory bean. So Spring allows you to Spring allows you to inject this object called JPA repository factory bean, which allows you to create a repository factory. So this way you can substitute the original repository factory with your own repository factory, and then inside of it you can provide a custom metadata. A metadata for every Spring Data repository holds all the additional information for this repository. Like for instance, the type for which this repository is assigned to, the finders, and etc. So if you go inside of it, we have for each JPA entity, we have a repository, and that repository has metadata. And when we create it, we say the domain class, and we have this private method here that just digs inside the meta model of JPA and then finds the class that we want based on the domain class that we're passing. So we're keeping a track of the domain class and the domain interface, and the domain interface is actually returned when you say the alternative. Yeah, so in Spring Data, they added in, I think 2 versions ago, they added this interface which is called get alternative domain type, which allows you to just specify more than one type for your repository. So now we're looking only not only for the interface but also for the class. And this actually solves the repository modularization. So now you have modules which have JPAs, which are modularized, and now the repositories are modularized. The services on top of that, they're also modularized because they work with the interface. If you have that module in the class path, you're going to have that interface in the class path. So you're straightforward can do that. And you're pretty much there, and you have your modularized architecture. And yeah, that's it. We also have done a little bit of tweaking on the auditing, which is pretty straightforward. You know, in every Spring, in every JPA, you have this so abstract entity definition. You can assign listeners, and Spring has provided this auditing entity listener, which listens for entities before being persisted to the database or after being persisted, and respectively sets this last modified by, last modified date, and etc. These properties for you, so you don't have to, you have to manually add them. And what we have actually done is we have extended our base entity repository. So we have auditable entity repository, which can actually, you can query by last modified date, after, and etc. And that's pretty much it. So now you have a modular application, and well, it works okay. It kind of works fine. So what you want to do is you want to deploy it somewhere, and the best choice, you know, to go for is deploy to the cloud. And if you want to deploy to the cloud, there's this 12-factor application principle that you have to follow. That, you know, the session should reside outside of your application. That, you know, it should be elastic and scalable and all that. And you have to expose everything via REST, or you don't have to package your administrative interfaces with your application, because, you know, when it starts scaling, that you have a lot of administrative interfaces with that. You just want to keep one separate administrative interface, and what you want to do is like make that administrative interface communicate with your application via REST. And this is what we have done actually. We made a JavaScript console that allows you to communicate with your application and, let's say, create new products, like create new prices and delete categories and etc. and basically administer all your application via REST. Okay, so moving forward, so I'm going to show you how it looks like, and I am going to, okay, that's interesting, it's trying to connect to the internet and it cannot, oh, doesn't matter. So I'm going to show you how it looks like, and I'm going to show you, you know, I'm going to tell you the problems that we were facing when we were trying to make it. So I have it here running, so you can go under localhost 8080/backend/login, and of course you have to log in. Right, so right after you log in, you see the left side, which is kind of like a tree view with all the modules that you have in your class path. So as soon as you add a new module to the class path, we actually show you the folder with all the entities that this module provides. So it's a wish list, or in case of commerce, and of course you can nest it forward, and etc. So then you can drill down and find the JPA entity that you want actually to administer. In this case, for instance, products. And then what you see on the right side is you see on the top you see a search form, where you can search, for instance, is starting, where the code is starting with Africa, and then, you know, you should be able to make perform like good search and complicated search queries. Then you can right-click it and see all the operations that you can do on the entity. Like in this case, I can edit it, or you can double-click it as well. And then finally, you should be able to see these details of the entity that you are editing. So first things first, what you want to do is you want to log in into your application. So let's go back. I am going to go one by one. So let's go back. What you want to do is you want to log in. Well, your application is a JavaScript application, and your server resides somewhere. And so what we have done is we have done like a manual post from the client. You pass two request headers. X nemesis username and X nemesis token password. And what you get back from the server is the X nemesis token. So this is pure Spring security. But the trick here is because in a typical Spring Boot application, Spring Data REST request handler is always after the Spring Boot application. So this way you can override your controller mappings. Like for instance, in your application, you can say, I want REST something else, and this will override if you have a something else like repository. So because because Spring Data REST request handler mapping is always after the Spring Boot application, what you have to do is you have to make sure you don't have filters that kick in, or etc. So or you have to exclude your filters from kicking in. Otherwise, you might just muddy the water and have this broken down. Right. The trick here, then the navigation. How the navigation is actually done is quite interesting. At the moment, we have a custom controller that returns the whole view packaged in folders in each other. So because I've opened here the Data REST 8.23, which actually speaks about being able to access the REST. So being able to access this REST representation, but in a more packaged way. So you can say, I want a projection here. I want only the category entities and etc. Well, it doesn't work at the moment, but there's an open issue that you can go there and vote. For the time being, we have all this on the left side just being returned from let's see, REST backend. Navigation. Yeah, so it gets returned from a custom controller, and then you have the ID of the folder, the text, and what kind of subfolders or children it has inside. All right, so moving forward. Well, next thing we want to do is you got to make sure that you handle the CORS. CORS stands for cross-origin resource sharing, because you're actually accessing with JavaScript, from a domain different than the one residing your application on. So your application could be on a, www.mydomain.com, and you could be accessing it from localhost and etc. Well, and how CORS actually works is, well, if I can, well, I hope you can see it. Cool. So if you're going to see it on the network here, so if I open it and then click on commerce, catalog, and then, for instance, product, it's going to issue several requests. Right. So the first one is going to issue CORS is not okay for. So the first one is going to issue is going to issue an options request to ask the server what kind of origins are allowed, what kind of methods are allowed to be performed, and etc. And then the server is going to reply with all the methods that are allowed to be performed on this resource, and then and all the origins, of course, and etc. So then you can perform them. At the time being, we were using our own CORS filter, but since 2 versions ago of Spring Framework, since 2.4 something, they introduced their own CORS filter, so we no longer have to do that. And yeah, it's actually, we can also configure it with Spring Boot. Right, so if you scroll down to the bottom, you have this course, allowed origins, where it's allowed from, what kind of headers you're allowed, and etc. It's actually got broken in Spring 1.4 because they changed the signature of the allowed methods, so it's no longer an array. It's now a list, but never mind. So yeah, this is something you have to consider when you're doing it, because again, JavaScript may access your application from another domain, and otherwise it's going to get blocked. So yeah, this is a representation of how course actually works. You have a user which makes an AJAX request through the client, and then sends an options request, and then the options response contains all the important information that the user must conform to, and then the client sends again the second one, say if it's a post, if it's a delete, or etc. Whatever has been approved by the server, and then the client again then gets the information. So moving forward, OData. Now this is all good and fine. What you have now is you have a single page application written in JavaScript. You can log in, of course. Now you have this menu on the left that has been served by a controller. And when you select, let's say, a product, you get presented with this nice view on the right side. This form allows you to search, but there's a couple ways to implement that search. Now, for instance, if you go under /rest product, the JSON that gets returned. Well, the whole idea of this Java's application is to conform to all the HADIOS and REST principles, and to keep it as dummy as possible, and just leave any logic outside of it and just keep it on the server. So the server should be the one telling you, what kind of operations you're supposed to perform, what kind of actions you're supposed to perform, what kind of links to follow, what kind of the whole pagination, all kind of logic should reside on the server. So in this case, if you want, the server also tells you what kind of searches you can perform. So any from Spring Data REST, you can get all the methods that you have defined in your repository. So if you go on the /search, you should see all those find by methods that we have defined in our product repository. Right. So find by approval status equals, for instance, and oops, is it here? Oh, that's interesting. Let's try another one. Okay, that's interesting. I have no idea why it's not exposed, but oh shit, it's not exposed. Yeah, it's marked as not exposed. Well, you get the idea. So if you want to implement this search, well, the first idea that will cross to your mind, or at least mine, was to get all these methods. They all start with find by something. So parse them. Just split them by the find by keyword, and then just populate these values, whatever it is. And it's actually a valid idea. I had this approach for about 2 months. And it was working fine. And then I decided that you can't really mix the conditions here. So if you want to search for something that starts with Africa, and then it has a catalog version of, let's say, staged, this one, you can't really have, if you follow this find by, you can only query one method, and if you want to cover all the different permutations, you're gonna end up with a lot of different methods here. So another solution, what we have done is we went to OData, and OData is, moving back to the slides, OData is actually a standard. I think it was started by Microsoft, if I'm not mistaken. It's a standard that allows you to define a protocol to query and consume like RESTful APIs through a very complicated queries. This is the OData website that you can go and read more about it. And in particular, we're using the Apache Olingo library. So, and just to parse the query, and here at the bottom, you can find out what it actually looks like. So you have a REST request, and then with a $ filter, you can specify some really complicated query, like starts with something, and then you can append also like Boolean queries like starts with, ends with, is bigger than, and something else happens. So it's very powerful. The way we do it is, actually I have another slide here. The way we do it is we construct this query on the fly based on what is here in these drop-downs. And then we send this query, let me show you what it looks. Right, so I have is starting with Africa and is equal to this value. And if I click search, this is performed, and this is being sent to the server. So you see it's, okay, I'm going to copy it, and I'm going to say URL decode. All right. And then decode. So what we have here is, well, this is some JavaScript parameter to avoid caching, and we have the size parameter to specify with how many you want to get returned. We have a filter, and this is the OData filter that we have here, and then of course we have the projection parameter, and we actually want the first page. So this gets sent to the server. So now what does the server do? Well, the server receives this, and then it has to somehow translate it into a Spring Data, into a query that Spring Data understands. So this is where actually Query DSL comes. Query DSL is a framework. It's hosted under querydsl.com that allows you to build very complicated database queries, which are well, type safe, and it has a nice fluent API, so you can say customer.created at is less than blah blah blah. So once you have these let's say predicates, you can pass them to a Spring Data repository, and then in this way you can create absolutely any query that you like. And what we need to do in this case is get the query that we get from the REST, translate it into a Query DSL predicate, and invoke the repository. And this is so good because since 2 versions ago, Spring Data started added actually a Query DSL repository, so which we extend. If you see here, we have a base entity repository which extends from the Query DSL predicate executor. So this Query DSL predicate executor has find one methods and find all, etc., and they all accept the predicate. So what you do is you take this OData Query DSL predicate builder that we have provided, data Query DSL predicate builder, and you tell it to use the Query DSL predicate parser. What? Oh. Something happened. Okay. Strange. Yeah, and then you tell it to use the Query DSL predicate parser, which internally uses the Apache Olingo library to parse the Query DSL, to parse the OData into Query DSL and create the predicate. So how do you plug this Query DSL predicate builder inside Spring Data? It's actually well, here's how. You have to create your own root resource information handler method argument resolver, and then you have to specify, well, they have one specified by default, but you have to substitute it so that you can use the OData Query DSL predicate builder. Yeah, and then once you have it, you declare it as a bean, and then they're not going to kick in. Their implementation will not kick in. Yours is going to be the one that is being used. And that's pretty much it. So next, moving forward, well, projections. So this is all good. You have now some backend administrative interface. You can log into it. You have this beautiful tree on the left side. and you have a search, and you got to display some results, right? When you search, and you got to display some results. But the problem is that the Spring data, what Spring data returns is like a really big JSON. If you have a look at one of those, like let's go to product. No. Let's go to product, and you see it returns all the first 20 results by default, and if you look at any of these, it's actually quite big. And this wastes a lot of bandwidth, back and forward. So if you want to design a performing, JavaScript application, you don't want this huge JSON coming back and you parsing it all the time and getting into performance problems. So what you can do is you can play a little bit about with the projections, which are actually the Spring Data way that allows you to limit the results that you get, and you also to transform the result that you get. So a projection is pretty much an interface that defines all the getters and setters, all the getters of the fields that you want to get. So in this case, when I have a product entity, well, in my case, it's a definition, but in reality, you're going to have a product entity which has, let's say, a content unit or a picture and a thumbnail. So what you're going to do in your projection is you're going to say get picture and get thumbnail, and then once you say here projection equals search, the name of the projection, you're only going to receive the fields that you have defined. So in my case, I have defined a product entity search projection, which has get active method, get catalog version, get description, and get name. So when I say projection equals search, I only get description, active, catalog version, and name, and nothing else. So this brings a smaller JSON to my client, and then because these are actually the columns that I actually need to display the result. I don't need the whole JSON, so it's kind of like performing better. Now my problems don't stop here because, like I said, I don't have access to the entity. I only have access to the definition, which is inside the module. I have this product entity definition. So when you specify the projection, you're going to have to specify here, what kind of entity this projection is for. So if I specify here the definition, like it's here, it's not gonna kick in. So how to solve this problem is the first thing that you can do is, because I don't have access to the JPA entities, the first thing that I can do is, upon Bootstrap, when the application starts, what I did initially was to use a CGLeap or a ByteBuddy to actually construct the class and put the annotations there, and then pass them to Spring Data and say, this is out of the box, these are the projections that I want. However, this really won't work because CGLeap is kind of like a really old library which doesn't support annotations on interfaces. And ByteBuddy is quite new, but I really had some problems, hooking it up into Spring. So what we really ended up is generating the projections on the client side. So now when you have, let's go back here. So now when you have here the generated entity, you also have the generated search projection for it, and it kind of looks like this. And of course, you can specify the add value annotation from Spring, and then you can transform, the type of value that we return. Because in reality, catalog version for me is an object, but when I access it with the search projection, I get a string, which is nice, and I can display it here in the search column so that the customer can view. So, okay. Moving forward. So JSON schema. So finally, you're getting somewhere. You know, again, you have this application. You can log in. You have the tree on the left side, and you can search on the right side. Well, how do you know what kind of options, what kind of actions you can perform here on when you right-click it? Well, this all comes down to Alps. If you've heard about Alps. Christoph was explaining Alps yesterday in his presentation, so I'm not going to focus too much of it. Well, my laptop is getting really slow. Okay, I think I had some curl command here somewhere. Okay. I'm going to just quickly have to type it because I don't have it. Accept goes JSON goes right. No, store font press slash profile slash product. Right. So when you type this, you get the Alps response for the product for the resource that you want to get, and then you can see all these operations like for instance let's see, create JavaDay product, patch, delete, update, etc. So you actually know what the server allows you to perform on this resource here. And then you can, of course, edit the product, and what you're going to get here is the view. So the view of the product and how to display it is another topic that the server needs to decide before pushing the information to you. Because, like I said, we want to keep this application as dummy as possible. So if you switch the implementation on the server, the JavaScript should continue to work because it didn't do a lot of calculations, etc. It was all done on the server on the fly. So how can we define the view and the layout of this pop-up window is actually covered by JSON schema. And JSON schema is another specification. Well, in our project, we're trying really hard to follow specifications, and then if one implementation does not perform, we try to switch to another implementation. I'm going to go quick. So JSON schema is a standard, is a specification which defines the metadata of a resource that you're trying to access. So if I try here and get schema plus schema, oh shit. Schema plus JSON, and schema, oh, why is it not coming? Application schema plus JSON. Interesting. Well, I really don't know what's happening, but usually when you specify the accepted type, you can tell Spring Data to return the schema for the JSON schema. See, no. My computer has blocked. Sorry. Localhost storefront press profile product. No. Well, I don't know. It's it doesn't like it for some reason. what you're going to get is you're going to get the JSON schema, which tells you, okay, this is the name of this property. Well, this is the description of this property. Well, the description doesn't come yet because we have filed at data rest 824. You can go and vote for it if you want. It tells you also what's the type. So in this case, you know, it's going to be a link to another type, or in this case, it's going to be a string or a localized value, or you have an enumeration. And yeah, this is actually all you need. The only thing that is missing is actually on which tab to display the property, and this we can't actually make with the JSON schema because it's not extendable. And there's this data rest 921. You can go and vote for that one too. Otherwise, at the moment we have a separate controller which tells us, you know, oh, this property goes under this tab, and then that property goes under that tab. Right. So resource processors. Although I'm running out of time, resource processors allow you to modify the resource after being completed by Spring Data. So if you can add a custom link, or you can modify a link that comes and so on. If you want to add a link under /rest, you can use the repository links resource, like we have done right here. At the bottom, we have added several, you know, results markup and all results markup and etc. And the profile link. No, the profile comes from Spring Data, and that's pretty much it. If you want to add a link under REST product search, you have to implement repository searches resource, or if you want to add a link under REST whatever entity, the ID of the entity, you have to implement persisting entity resource. The same goes with resource product entity, which will add a link only under product. Well, what if you want to add a link under REST product? Well, that's not possible. There's a data rest 817. If you like it, go vote for it. So moving forward, well, validation. If you want to perform some validation in case, you know, you want to, let's say, create a new product, and then when you create a new product, let's say save, you want some kind of like simple validation to appear. So this is actually quite an interesting topic, and I'm really sorry that my time is ending. Right, so Spring Data, you can hook up the Spring MVC validator into your REST configurer, like here. You know, Spring MVC comes with MVC validator that takes the validation messages, and then there's this local validator factory bean. You can hook it into your validating repository event listener on the before create and before save events, and then you can configure it to use these message properties that you want. And in this case, you're gonna end up with, you know, these are the message properties for your storefront. So you can say blah 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 is required, and then you can put your Spring Data messages here. So you get really nice validation, you know, connected to your storefront. And of course, you also have these. Let's see. You also have these src main resources REST messages properties, where you can localize, you know, the description for a certain attribute in a certain resource. And also the title, and in this case we use it like you see. If I pass on my mouse over unit, this comes from the REST messages file. Well, it's all nice and interesting to follow. Like several limitations, there's several limitations I have discovered and that I have filed in the Spring Data Jira, but I don't want to leave you with a bad feeling. It's a great project. I love it. It's actually one of my all-time favorite projects, and yeah, there's a lot more that we can improve, but it's overall it's great. So it's awesome, and that's my time. So you can stay in touch with me, or you can ask a question, or you can go and grab some lunch.
Awesome. You have shown us how to build such an application.
Sorry?
Does it work?
Yes.
So you have showed us how to build a pretty complicated application.
Yeah.
And a big part of the code is auto-generated, as you have shown us.
Yeah, the entities are generated, yeah.
So I would like to understand where, if we have to develop such a project, where our manual work will be focused, where we will have, let's say that we have at least big application that would like to be Spring Data REST.
Mm-hmm.
And we can rely on a lot of generated code, on a lot of infrastructure, from what I have understand.
Mm-hmm.
In which places should we think that we have to do a lot of manual work on our side?
Yeah, I think Spring Data REST gives you a lot of stuff out of the box. However, there's like, you know, the validation is not great. You can also hook up a validation with JSON Schema, right? A client-side validation, because JSON Schema tells you, oh, this property is required, or this property, you know, is an integer, but you're passing string. So you can also build your client-side validation with JSON Schema. So there's like a lot of stuff that you can, a lot of things that you can hook into and you know, upgrade it this sort of way. Otherwise, it gives you a lot of REST, the whole REST stack out of the box, but it's absolutely not perfect, because validations and cores and all those kind of things that you have to think about yourself. Yeah, does that answer your question? Oh.